In Learning Objective A, we're going to learn how to set up trig ratios and solve for side lengths on various triangles. Now, the first thing you want to remember from geometry is when we did the trigonometry with sine, cosine, and tangent, there was an acronym that helped you remember the ratios. It was SO, CA, TOA. And what SOHCAHTOA stood for was the sine, the cosine, and tangent, and it talked about the sides of a triangle that were related to it. So for this theta that's listed right here, or this angle, let's actually find sine, cosine, and tangent and set it up. So for this angle, let's do the sine of the angle. Now the OA stands for opposite over hypotenuse. And remember the opposite, just go to the angle and go straight across. That's called the opposite side. Adjacent means you touch the angle, so this is the adjacent side. And the hypotenuse is always straight across from the right angle. So for sine, opposite is 12. And the hypotenuse we don't have quite yet, so we'll just put hypotenuse. Now, for the cosine of the angle, that's the CA, which is adjacent over hypotenuse. So the adjacent side is 5 over the hypotenuse, which we'll find in a bit. Now the tangent is the tan of the angle. Tangent stands for the TOA, or OA, is the opposite over adjacent. So the tan of the angle is going to be 12 over 5. Now, if we wanted to come in here and actually put a value in for this hypotenuse, think about how we can find it. Remember Pythagorean's Theorem, a squared plus b squared equals c squared. Let's go ahead and do that and get the value. So we're going to have 5 squared plus 12 squared equals c squared. 5 squared is 25, 12 squared is 144 equals c squared. So we have 169 equals c squared. To get rid of the square, take the square root. The square root of 169 is 13. So we can actually come up here and adjust these fractions. So the sine of theta is 12 over 13. The cosine of theta is 5 over 13. And our tangent stays the same as 12 over 5. Okay, on this problem, they want us to find the value of x. So what you want to do is you want to look at the angles that they've given us. They gave us 30 and 90. They didn't give us this one, but we could easily find it, by the way. A triangle is 180 degrees, so just subtract the 90 degrees and the 30 degrees, and you'll get the remaining 60. So if you want, feel free to write in here that this angle is actually 60 degrees. Then what you want to do to find the missing side length here, because we only have one side length, we can't use Pythagorean's theorem. When that's the case, you can write a ratio, either sine, cosine, or tangent. What you want to do is pick an angle, and we're going to use 30 degrees, and see which sides you have. Well, this one straight across is called opposite. Again, this is the hypotenuse because it's right across from the right angle, and this is adjacent. So the two sides we have are the adjacent and hypotenuse. Now which ratio is that? For SOHCAHTOA, that's the cosine. So set up the ratio. The cosine of the angle, which is 30 degrees, is equal to adjacent, which is x, over hypotenuse. Now all you have to do is go in your calculator and type the cosine of 30. Be very careful. Check the mode that you're in. We are using degrees. So your calculator must be in degree mode, not radian mode. So the cosine of 30 degrees in your calculator is 0.866. Then we have x divided by 8. To get x by itself, just multiply both sides by 8. Then you're going to find that x is equal to approximately 6.9. Double check for reasonability. The hypotenuse has to be the longest side because it's across from the right angle. So this has to be less than 8, and 6.9 seems reasonable. Let's look at this problem. Sonar on a salvage boat locates an object at a downward angle of 50 degrees. So here's how the sonar works, by the way. They turn it on and imagine the sonar is reading out this way. That sonar then moves at an angle downward of 50 degrees. So that's why this is where the 50 degrees is. Then it says, in a distance of 510 meters, it locates the object. So this is really the sonar. So again, imagine turn it on here, and then when it kicks in, it goes down and it looks, and here's where it found it, 510 meters down. Looks like it found a shark. How far below the water is this object? So D is what we want to find. So the image is already drawn here, and it's a right triangle. So what you can do is, unfortunately, we can't use Pythagorean Theorem because we only have one side. So you use SOHCAHTOA. And again, just look and see which sides you have. Go straight across. That's called opposite. This one here is the hypotenuse. So what ratio uses opposite and hypotenuse? It's the SO. So it's sine. So do sine of 50 degrees is equal to opposite over hypotenuse, D over 510. And then go ahead and solve using the algebra. All you need to do is get D by itself. So instead of dividing by 510, you multiply. So you'd multiply this side by 510. So on your calculator, what you're going to type is you can type 510 times, hit the sine of 50 degrees. Again, make sure you're in degree mode. When you do that, you're going to get approximately 390.7 meters is the distance. Again, do your gut instinct to see if it seems reasonable. The hypotenuse is always the longest side. 390 meters seems reasonable. That's our answer. In this scenario here, you wonder how tall a grain silo is. You walk 60 feet from the silo and find that you have to look up at a 38 degree angle to the top. So what you did is you started here, you walk 60 feet. Now be careful, you look up at your eye level. So initially when you look at your eye level, you're looking straight ahead. So what happens is your straight ahead distance, this actually moves upward, and this is where the 38 degrees gets created. This is called a 38 degree of elevation. And then you identify the top of the silo. It says here your eyes are 5 feet 3 inches off of the ground. How tall is the silo without the roof? So what we need to find is the full length of the silo. Based on what we have, what we could first do though is, why don't we find this distance and call it x? This is a right triangle. You can assume buildings are built at a right angle. So if we find x, then all we need to do next is add this little extra part to it, which is going to be our height of 5 feet 3 inches. So what ratio should we use? Well, I know here the opposite side is what I want to find, and this is the adjacent side. So from SOHCAHTOA, TOA or tangent is the one that we want, opposite over adjacent. So that do the tan of 38 degrees equals the opposite is x over the adjacent. On your calculator, you're going to solve for this, and you're going to multiply both sides by 60. So what you're going to type is x equals, take 60, then times it by the tangent of 38 degrees. Be in degree mode in your calculator. When you do this, you're going to get 46.9 feet. So that is the height of this part of the silo. Now we do need to add ourselves back into the height. Be careful, this is 5 feet 3 inches, so let's convert that to complete feet. So it would be 5 feet, and then it's 3 inches out of 12. So this really becomes 5.25 feet. So let's add that to the 46.9 feet, and we'll then get that the total height here will be approximately 52.15 feet. Now if we round to 1 decimal, this actually would round up to 52.2 feet tall. Now I think it's important to show you another way to solve tangent. When they give you two of the three angles, in this case we have 38 degrees and 90, I could have used this angle instead because I can just take 180 and subtract these and realize that this angle measurement here is 52 degrees. So what I could have done to still find the same x height of the red line is I could have used the green angle. And what I would have written is I would have said the tan of 52 degrees is equal to opposite over adjacent. So that would be 60 over x. Now the reason I want to highlight this formula is because students will get confused when x is on the bottom. Don't worry about it. It's very easy to solve. All you have to do is when it's 60 divided by x, to get rid of the division, you would multiply both sides by x. In doing this, we would then write x times the tan of 52 degrees equals 60. Now this just says x times the tan of 52. How do you get rid of the tan of 52? Well, you can divide by the tan of 52 on both sides. And if you do that, what you're going to end up getting is x equals 60 divided by the tan of 52 degrees. When you do that, you're going to get the same answer we got before of 46.9 feet. So what I showed you is really a second option you could have used to find this height of the silo. But I also really wanted to highlight what if the variable we're trying to solve is on the bottom of the fraction. Don't let it throw you for a loop. You can just do the algebra to move it to the other side and make it easier to do. And here's the last one. For safety, in climbing a ladder against a wall, the ladder should ideally make an angle of 75 degrees with the ground. So what you're seeing here is the ladder and the ground, the 75 degree angle. If the ladder is 12 feet long, so it's right there, how far from the wall should you put the base of the ladder? So the question is, what should this side length be? All right, let's look and see what ratio we have. We need to have the hypotenuse side, and we need the adjacent side. So this would be cosine. So we're going to do the cosine of 75 degrees equals, it's so katoa, so adjacent over hypotenuse. To solve for x, multiply both sides by 12. So in your calculator, you're going to type 12 times the cosine of 75 degrees. And what you're going to get is that the distance for the base should be about 3.11 feet. Now I do want to show you a second way you could have done this problem. And now instead of looking at 75 degrees, because this is 90, we know this third angle had to be 15. So if you wanted to, you could have written the sine ratio, because 15 degrees, this side would be opposite and hypotenuse. So you could have done the sine of 15 degrees equals x over 12. If you multiply both sides by 12, you would type in your calculator 12 times the sine of 15 equals x, and you'll get the same answer. So you don't always have to use the angles they give you. You can always compute other angles if they're missing in the triangle.